Good evening, sir.
Good evening.
Good evening, sir.
Good evening.
Sir, we can start, sir.
Okay. Okay. Today we are going to talk a new topic, which is also very one of the important topic, which is called as signal conditioners. Correct? Signal conditioners. Signal conditioner. We know that sensors are producing signal proportional to input parameter. For example, if you take a thermocouple is going to measure temperature. If temperature changes from example 0 to 400 degree, and the thermocouple may give 0 to 50 millivolts proportional voltage is going to give. That is what sensor signal. But please know that the sensor signal, we saw the functional block diagram of mechatronic system. Okay, when we talk about functional block diagram, I will draw a miniature version. I have my set point. I wanted to, for example, I want to control engine speed. Correct? So set point we call RS. Then that is given to one input called plus input, and the other input is the actual the engine speed. Set point I say 1000 RPM. Engine speed I want to maintain. Correct? SA engine. So then this is the actual current engine speed. We are measuring using a sensor. I have a sensor which measures engine speed sensor. Okay. Now this is my engine. This is my engine. Here I am controlling fuel quantity. Fuel quantity I am controlling. Injected fuel quantity. We know that if the fuel quantity is varied, torque increases, automatically engine speed. The output is engine speed. Correct? I say omega. Omega S is engine speed. So this is my output. I am measuring this using a sensor. This is the engine speed sensor which measures omega of the engine. So this sensor gives a proportional voltage. Correct? This is engine speed varying from 0 to, for example, 10,000 RPM. I have single cylinder engine which is going to vary from 0 to 10,000 RPM. If engine speed varies, this is the output of the engine. The sensor will give 0 to 10 volts. Okay. This is called a set point input. There, what I'm giving is a voltage I'm giving 0 to 10 volts. If I give 0 volts, that means I want to run the engine at 0 RPM. If I give 10 volts, I want to run at the engine RPM 10,000 RPM. So that is called as set point at this one. That is given as input here. This amplifier is called an error amplifier. Note down. We call this error amplifier. What it does, it compares the set point, which is I mentioned RS, and the actual speed is measured using engine speed sensor. I say that this is, for example, BS. I can give any name. I'm saying BS. Now, here this output, that is called error. Error E of S. Note down, error E of S equal to RS minus BS. Okay. So now the error signal is this. This is given to a controller. This is your ECU, electronic control unit. Now, electronic control unit generate fuel pulse width. I say that T, pulse width modulation, T PWM. So we know that PWM pulse width will be varied from, depending upon whatever the torque you want to generate, you can generate different this one. So if I vary this width I call TW. Correct? This is the injection pulse width. If I vary the injection pulse width, for example, 1 millisecond to 5 millisecond, or for example, ECA 10 millisecond, I'll say that my engine RPM will vary from 1 millisecond with 1000 RPM ideal speed, 10 millisecond fuel injection duration give means it is going to give 10,000 RPM, full speed. So that means by varying the fuel quantity, who is varying? EC is going. EC will vary depending on the error. If error is there, so we are giving 2 voltage, 1 voltage set point, it varies from 0 to 10 volts. In that case, it will be compared with the actual engine speed. Then error is given as input to the ECU. ECU generate 0 to 10 millisecond duration pulse width. This pulse is the pulse width modulation. So this is what we call a closed loop control system. Correct? All mechatronic systems are controlled using closed loop control system. Now, what I want to say is, now this signal coming from the engine speed sensor. Already we saw the photo sensors or inductive sensor. All this thing, the output will be in the order of, we know the pulses are coming. Each time in this one, this pulse will be in the order of millivolts only. Already we saw the strain gauge sensors. Correct? Force transducer, pressure, all those things. The output will be in the order of millivolts. When the input is varying, where the force is varying from 0 to 10 Newton force. So the output is 0 to 100 millivolts. This is what the output from the force transducer. The output is varying when force is varying from 0 to 100 Newton. This one is varying 0 to 100 millivolts. So we see that most of the sensor, the output will be under millivolts, microvolts. Again, I will tell you, take a thermocouple. Chromal element thermocouple, which can measure, for example, temperature 0 to 1200 degree is the temperature it can measure. It will produce a EMF plus minus EMF will be in the order of 0 to maybe 100 millivolts or 120 millivolts. So any sensor, if you take the force, pressure, all these things, the engine speeds, all these things, generator voltage will be the millivolts. So those signals should be amplified before giving to the ECU or to the control system. So for that only, we need to design what we call as signal conditioners. Signal conditioners, there are two things are there. One is called as amplifiers. Other one, what we are going to use later, next class is going to be filters. Correct? Which is called an electronic noise filter. Note down. That we are going to talk separate next class. Electronic noise filters. Okay. Today we are going to talk about amplifiers. Specifically, when we talk about amplifier, if you see that people always talk about a transistor. Transistor can be used as an amplifier. Note down. Correct? Transistor can be used as an amplifier. There are two types of transistors there. One is called PNP transistor. Other one is called NPN transistor. Yep. Please note that transistor is made of semiconductor material. It is made of semiconductor materials. Correct? So one is called P-type material, other one is called N-type material. So if you see the, for example, PNP transistor, this is a whole transistor because please think that it is a cylindrical shape, solid cylindrical shape like this. This is divided into three portions. The first portion is doped with what you call as trivalent